Hello everyone, thank you for coming. Today I'm going to be talking about the new features in Source 4.1, which is the new production release of Source that we made in August this year. Source 4.1 makes many improvements over our first public release of Source, which is version 3.7 and is the release that we made in 2014. In today's webinar, which is going to be about 20 minutes to half an hour, I'm going to give you a brief overview of the new features, focusing on some of the tools that I think are most complex or particularly interesting. And coming up next month, we'll have two one-day courses that will go into these new tools in more detail. So I'm going to cover 7 topics today. To start with, I'll look at model management tools, which are new project and scenario settings. We'll discuss performance, new tools for working with and manipulating networks, function enhancements, scenario input sets, which are a really exciting new feature that enables you to create alternative model configurations, the new groundwater model, and the results manager, which is our new data analysis tool. I'll finish with a brief summary of other new features and enhancements that are available. Some of the features that I'll be talking about today are not available in the public release of Source, and these will be denoted by an asterisk and bold text, and they are just available in Source Full. If you have any questions during the webinar, you can type them into the GoToWebinar panel on the right of your screen, and I'll stop at a few points during the presentation to answer any questions. We'll also be answering questions at the end of the webinar. To start with, I'm going to talk about the new options that we have for model management. We have two classes of options. The first are project options that affect all scenarios within a given project. These include an improved dialog for specifying your unit's preferences that categorizes unit types by things like whether they're groundwater or stream flow or rainfall data units. We also have new settings that improve your control of audit logging, and you also have the ability to delete audit logs, which can reduce your project size. We have many new options for setting your scenario configuration, so an individual scenario within a project. These include, well, they're listed on the right-hand side of the screen, but a couple of them that I find particularly interesting are the assurance rules that enable you to control the notifications that you receive when you're running a model. So perhaps you can set whether an error will be fatal and stop the simulation, or if it will just be reported as an error or a warning. We also have custom running configurations, and these are really useful, particularly for model calibration. So you can create a calibration settings using the calibration wizard and save these rather than having to recreate them next time you want to recalibrate that catchment. We also have new tools for controlling node execution order, and this is really useful perhaps if you have two branches in a network and perhaps some functions linking them, and you want to control which branch of the network is executed before the other. We also have made significant improvements throughout Source in performance, and this includes the speed of the user interface and feature table editing, and it also includes the execution speed of the models themselves. As well as the general performance improvements, we now have some user configurable performance options. These include the ability to run separate networks and sub-catchments in parallel, and also to generate water user orders in parallel. Finally, we have lots of new tools for importing, manipulating, and configuring your networks. We can copy and paste nodes and links, and this will also copy and paste their associated data sources and functions. We have a new node called the scenario transfer node that enables you to dynamically link scenarios. We have a scenario import tool and also a scenario difference tool, so you can quickly identify the changes between two scenarios. So I'll stop the presentation there and demonstrate some of the features we've just talked about in a source model. So here you can see I've already created a catchment scenario, and I'm going to look at in schematic view. We have two inflow nodes coming down to a storage, and then some outflows from the bottom of the network. First of all, if we go to edit project options, you can see the new, options for configuring your scenario and your project. We'll start with the project options. Here we have our audit log settings that enable us to clear our audit log and enable or disable the logging. We also have our new units preferences menus. You can see that they're categorized by data type, and we also have defaults for uncategorized units. I'll go OK to close that. If we look at our scenario options, we'll see that we have many configurations that we can set. Up first in the list is our assurance rules that enable us to choose what type of error reporting we want for different types of errors or messages in the model. We can choose our custom running configurations, so I can save my current setup if I like, and you can see I have single analysis and my start and end dates for the scenario. I happen to have a flow calibration analysis already configured in this scenario, and I can also save that, and I can reload these at a later date. I'll show you how to do that in a moment. And the third point to draw out was our execution order rules. You can see here the current execution order of our nodes, and we're able to control this and change the execution order as we please, within the physical constraints of the network, of course. For our performance options, if we go to the performance item here, we can see that we have the option to run catchments in parallel. So that would be your rainfall runoff models and flow generation. By default, we are processing water user orders in parallel. And finally, if we close that and go to our single analysis configuration option, we can see that we can run our separate networks in parallel. So these parallel performance options will enable Source to utilize all the cores on your laptop or PC to speed up execution time. Now here, you will also notice that we have options for loading different scenario input sets, and I'll talk about that a little bit more in the future. So we'll go OK. Now the other tools that I mentioned were our new features for working with networks. The first is the ability to copy and paste nodes. So I've selected 3 nodes there. I can use the shortcut key Control-C, or I can right-click and say copy. And then I'll move to another catchment scenario, move to the schematic view, and I can paste those 3 nodes. They will retain their geographic coordinates. So as you can see here, they've been placed in the same positions that they were in the other scenario. And of course, you'll need to link them to your network if you'd like to do that. We also have the option to import new scenarios. So if you go to File, Import Scenario, you can import a scenario from another project. I won't demonstrate that. A particularly useful tool is the Scenario Difference tool. So if I go to Tools, Diff, I can load a project, and this can be any project. It doesn't have to be related to the one that we're currently viewing. So I'll open 2 copies of the same project, in fact. Clicking the Find Difference button will actually just load those 2 projects into Source. Here we're actually loading the same project twice. Now I can choose which scenarios within those projects I'd like to compare differences. So if I look at the network elements in the 2 scenarios, we can see that we have a few node types that are in my left-hand scenario, which is project 1, that are not present in our right-hand scenario. So I'll close the difference tool now. And I'll move back to my source model. Now, the final tool for our scenario management that I wanted to mention is the new scenario transfer node. So if I go to our node palette, on the right-hand side of the screen, you will see we have a blue and green scenario transfer node. It's shaped like a circle. Now, I've already created one in this project, and you can see that we can only see half of the scenario transfer node, and this is the upstream connection. If I go to my second scenario, this is a schematic scenario rather than a catchment scenario, you can see that it also has a scenario transfer node in the model. And I'm going to use these two scenario transfer nodes to dynamically link these two projects. Some of you might already be familiar with scenario data sources that you can use to link projects. The scenario transfer node is similar, except for rather than having to individually rerun both projects, the scenario transfer node effectively creates the two sub-projects as one model when you run it in source. So it's dynamically linked and you don't need to individually run the separate projects. You can, of course, still choose to run each of those sub-projects on their own, but it gives you that flexibility and it's really convenient for working with large models, or perhaps for enabling two people to collaborate on working on separate components of a large model. So to configure the scenario transfer node, I'm going to double click on it to edit it. I'll have a slight problem there. I'll double click to edit. So I'm going to tell source which scenario it should be connected to, and that's my demo start project, and I'll tell it which scenario transfer node it should be connected to, and I've called that outflow. There's only one scenario transfer node in that project, so we don't have many choices there. And then I'll go OK. You'll have to close the editor. But before that, I'll just mention if we run the scenario transfer node in disconnected mode, so that's where we're not dynamically linking the two projects, then it will act as an inflow node if we run it in disconnected mode. So we'll go OK. And then you'll see I've already selected linked analysis in our scenario type. I'll configure that, and I'll tell it that we want to link it to our upstream scenario. We can now automatically change our start and end dates so that they're the same for both scenarios. Go OK, and we can run the model, and that will run those two scenarios as a single dynamically linked model. So at this point, I'm going to ask if there are any questions so far, and if not, we'll move straight on to functions and scenario input sets. So the question is, when we start up source 4.1, the log reporter is the default taskbar at the bottom of the screen rather than the recording manager as previously. Is there a way to change this? No, sorry, I don't think there is a way to change the default view. It is now, as you mentioned, defaults to the log reporter. The reason for that is that the results manager is, the old recording manager is now superseded by the results manager, and I will demonstrate that at the end of this webinar. If that's all the questions so far, I will move on to our next features. So I imagine most users are already familiar with functions, which is Source's tool for writing your own logic and equations. In 4.1, we've introduced a number of new function types, which include two-way lookup tables and bilinear variables. We've improved access to functions in many of our nodes and links, so variables that were previously only able to be set as constants or similar can now be set using functions. And what we have that's particularly useful is new tools for viewing and your function usages and also deleting unused functions. Secondly, we have significantly expanded scenario input sets. Scenario input sets are one of my favorite features in Source, and they allow you to create and store alternative configurations of the same model. So through scenario input sets, which are a text file configuration of the model, you can change your input data, your model parameters, and also even change your model structure through node deactivation. Scenario input sets are linked to the export summary tool, which provides an overview of the features in Source that you can access through scenario input sets. So if you're ever looking at a model and you're wondering which parameters in this model can I edit, what settings about the nodes, what structure can I change, if you look at the export summary, that will give you an overview of what you can change through input sets. So now I'll go back to my demonstration project, and we'll start with examples of functions. So if we go to the function manager on the right hand side of the screen here, you can see that if we click on a function, we can see what nodes are using it, and that's something that's been available in Source for quite a long time. What's new is if we go to the function editor, we have two new options. If we click on a particular function, we can click this button here, and this will show us the functions that our function uses. So I'll go to a different function. I'm not sure what's happening with my mouse. Sorry, I'm having a problem with my mouse on this computer. So I'll click on my demand function, and again I can click this button and see that it uses the inflow function, which uses the now.day variable. Also, we can look at the inverse of this, and that is to see what functions are using our function. So if I click on that, toggle that button, we can see that the inflow function is used by water user demand and our water user return flow. And this becomes really useful when you have a complex model with a lot of functions and really complex relationships between them. Also, I'll toggle that off. We can filter our functions to just show used or unused functions and variables. So I'm going to filter for unused functions. Then what we can do is we can delete all unused functions. You'll see that I have 3 in this project that are not used by any node or any other function. And if I click that, they'll automatically be deleted from the project. And I'll just turn off the filter to show all my functions again. And that's a really useful tool for cleaning up your project. It often happens when you import nodes, say copy and paste nodes from another scenario, that you might also import a lot of unused functions. Or import a scenario from another model. So we'll close that, and next we'll go on to look at our scenario input sets. For that, I'll go back to my original catchment scenario. Now if we go to Edit, Scenario Input Sets, we can see that we have one running configuration for our model. I'm going to create a new one. And this option here is asking you what data do you want to use for your scenario input set. And I'm just going to use the same data that I've already loaded for the default input set. I'm going to rename this input set and call it wet conditions. So here I'm going to set up a scenario configuration that represents a hypothetical set of wet conditions in my catchment. And I'm also going to edit some of my model parameters. So I'm going to start typing, and I've typed in nodes, which displays for me a list of all the nodes available in the project. I'll choose my storage. I'll click dot, and it's got this autocomplete action, and I can see that I have the option to deactivate the storage. And I'll assign that to true. So when I run this input set, my storage node is going to be deactivated. I'm going to change my default input set to make sure when it's run that my storage is active. So I'll put deactivated to false. Now that I've changed some of the parameters in my model, well, actually, before I go on, I'll show you the other options. We can look at all the different links in the model, and we can see what types of options are available for that link. Generated link number 1 is just a straight through routing link, so there isn't much we can do there. We can just set the elevation, change it to 1 meter. So I'll go OK. So you can edit just about anything in the model there. It's really cool. Now I also want to use different input data for this wet scenario. So I'm going to go to my rainfall data source, right click and say edit. And I'll click on this little tab here, add new tab. And I'll say use this data for my wet conditions input set. I'll go to my file and I'll load a input CSV file of rainfall data that I've prepared earlier. Change the units. And it's in units of millimeters per day. I'll also tell source that we're now only using the old data for the default input set, and we'll go OK. So now, if I close that, if I go to single analysis and press configure, I have the option to use the default input set or run using the wet conditions input set. And that will use different input data and different network settings. Rather than running the model, I'm going to show you one more really useful feature there. So I'll go back to my input sets. We have the option, first of all, to load our input set from file. This is one that I saved out earlier. And this is really useful because obviously you can then change that input set using external tools such as, PEST or some other calibration program, and tell source to reload that file every time it runs with whatever new settings you've made. Also, this little exclamation mark button on the far right hand side enables you to change to apply the scenario settings to your scenario immediately. So if I click that button, it will give me a warning because it is just about to change my model. I'll click yes, go OK. And now you'll see that my storage node has been deactivated. So if I run the model now, the storage will have no impact on the network. Okay, before I go on, are there any questions about our functions and scenario input sets features? Okay, we'll continue onward. One of the new models that we've developed in Source 4.1 is the numerical groundwater model. It's a lateral finite difference scheme, and it performs similar functions to the analytical groundwater tool that some users might already be familiar with. The differences being is that it's, rather than solving the analytical equations for groundwater flow, it's using a finite difference scheme. It can be significantly faster, particularly if you have time-varying inputs and drivers of the groundwater model, and that was one of our main reasons for introducing it. It's designed to simulate the stream aquifer flux and provide estimates of groundwater heads moving away from the river. Like all of the groundwater tools built into Source, it is aimed to improve the calibration of our rainfall runoff models and to enable analysis of conjunctive water use. It's not designed to be a full-blown regional groundwater flow model. If you would like to do that type of analysis, we'd still suggest that you use a tool like ModFlow, perhaps, as the most popular choice, and link it to Source. Related to the groundwater model, we now also have automatic generation of rating curves from river cross sections, and I'll demonstrate how to use that tool in a moment. We also have the new results manager, which supersedes the old recording manager. It performs the same functions as the recording manager, but introduces a lot of new features, and these include new chart types, the ability to create custom charts that will persist. So every time you save and reload your project, those charts will still be there. We've got new options in our univariate and bivariate statistics. And we've also got some really useful new tools that we call transforms that enable you to manipulate your time series data and say, aggregate it on a monthly or an annual basis or filter it for a particular date range. So I'll move back to my model and we'll see, first of all, demonstrate how to create a numerical groundwater model, and then I'll run it and we'll have a look at the results manager. So we create a groundwater model on a storage routing link. And one thing to be aware of is that groundwater models on separate links at this stage don't interact. You can enable them to interact by using functions or custom functions that you've written yourself. And it's something that we'll be probably building the source into the future, but at the moment it's one model per link. Now you'll see that I've already created a groundwater model on this link. So you do that by clicking on the groundwater icon and then selecting one of the choices of groundwater models. I've created the new saturated numerical groundwater model. I've created some basic settings. These common controls at the top are your basic hydraulic or hydrological catchment settings, so your transmissivity, the distance to the no-flow boundary, the specific yield of the soil. The second field here is the model parameters, so that's the settings for the numerical finite difference scheme. The divisions per bank, for example, it indicates the number of divisions that the finite difference scheme will use, and the more divisions you have, the greater the accuracy, but the longer the runtime of the model. We also have a simple unsaturated zone model based on the mean-Larsen equations, which are a formulation of the green ant infiltration equations, and I won't go into that in detail today. A key feature of the groundwater model is that it needs to have a cross-section of the riverbanks. So this one I have already created in a CSV file and loaded. So I've clicked on that CSV file and opened it. And it just describes the geometry of the riverbanks and the river itself. And importantly, I tell source where the left bank and the right banks of the river are located. So if we go OK, I also wanted to mention that we can now generate a rating curve from that cross-section. So I've already generated one here, but I'll show the process of doing that. If I right-click on rating curves, I can go add rating curve, which would be your normal process, or add from cross-section. I'll click on that groundwater model cross-section, go OK, and it's going to generate a rating curve based on the Manning's N and slope parameters that I've configured. There we go, we've just generated another rating curve. For our saturated numerical model, you can see I've already added an observation bore to the model, and it's at position 6,240 meters in our coordinate system. I'm also going to add a groundwater pump to the model. You can see we can also add injection bores and diffuse sources that might represent rainfall or irrigation inputs. I'll tell the model where the pump is located in the system, and I'll put it at the same position as the observation bore. And I'll also set a pump rate, and for this I'm just going to use a function that I've defined earlier. We'll go OK. Now I will simulate the model. Done, and we'll open our results manager. You can set this to open by default, or you have a shortcut key, which is F10, to open it up. As you can see, I've done a lot of other runs in this project previously, but we're going to look at the latest run. So this is currently pointing to the results of run number 9, but if I run the model again, the latest run will update to point at the results of the latest run. I'll show you why that's useful in a moment. So we'll go to our storage routing link, look at our observation bore, and look at the water table height. And this shows you the groundwater table height at our observation bore, and you can see that in 1986 I've turned the pump on for 6 monthly intervals, and you can see the resulting drawdown in the aquifer. I didn't record this, but you can also then look at the impact on the downstream flow in the river due to groundwater losses and gains. So the new results manager is quite similar to the old recording manager in some ways and very different in others. First of all, we'll see that we have 4 tabs across the top of each chart here. Looking at the visual display of the chart, and we have many different types of plots that we can use here. On the table view, we can see a tabular version of the data. We have these transforms, and these enable us to apply user-defined transformations in our data. I'll show you how to create those in a moment. And we have statistics. So this chart only has one time series, so we have some univariate statistics that are displayed. I'm now going to show you how to create a custom chart. So I'm going to look at my inflow. I won't use for my inflow number 1. Actually, that's not particularly interesting because it's flat, but that's all right. And we'll look at our groundwater table height. And if I click, right click and go add to custom chart, new custom chart. And we can also add a groundwater table height to that custom chart. Add to custom chart 1. And for this example, I might put the I'll show you can delete one series. So right click and delete our downstream flow. And I'm just going to rerun this model with different inputs so we can get a new, more interesting output. So I'm going to configure it and use our default input set, run it again. Okay, I think I've failed to load some of my input data correctly, or used the wrong input file. But I'll continue with the results that I've got because we should actually have some time varying flow shown in there. We have one question. Does the groundwater model have salinity parameters? No, the numerical groundwater model doesn't have salinity parameters, but the old analytical tool is still available, and it did enable you to do some salinity simulations. So for my custom chart that I've created, I'm just going to rename it and call it comparison. Now, if we go to the statistics, we can now see that we have bivariate statistics available that look at some common statistics that we might use in calibration, and also some basic analyses of the data, like how many missing values we use, the correlation, and other things like that. If we go to the transforms, you can see that on the top right-hand side of my results manager, I have this colorful wand icon. If I click on that and go to the plus sign, we have a range of different transforms that we can add to the data. Some of them enable you to filter the data by values or percentages. We have a transform that will invert your data, and a couple that will filter your data for different date ranges. I'm going to look at the aggregator. So I'm going to aggregate my data on a monthly basis, and the method I'll use to do that is the mean. So I'll call this transform monthly mean and go OK. Now that I've created that transform, it appears in my list of available transforms for my custom chart. So I'll apply that, and if we look at our charts and perhaps zoom in, you can see that our groundwater data is now significantly smoothed. I'll expand that out a little bit. Also, I can apply a repeating date range filter that I've already created, and that just selects 6 months of the data every year. If I now go back and look at our chart and zoom in on a particular component, so I'll apply that again. Okay, I will apply that to my groundwater data here. And now you can see we just have a 1 6-monthly spec of our data that's been enabled. So if we create another date range filter, and let's run it from 1985, which is the start of our data. I chose 1986 to 1999. If we go OK and apply that to our data, we can now see that we've filtered the display time series to just that date range. So those are some of the really useful features that you have in the new Results Manager. So do we have any questions on the tools that I've demonstrated so far today? No questions? To finish up, I'll just briefly mention some of the other features that are available in Source. We have, for feature tables, which are a tabular way of editing your nodes and links, we can access many more settings than previously available. So before it was just some basic node and links types, and now it's expanded to many other features in the model. For storage nodes, we can now do time-varying reservoir dimensions. The calibration tool has a number of enhancements, including new objective functions and improved default parameters for optimization algorithms, particularly the shuffled complex evolution algorithm that has 6 or 8 parameters that you need to set depending on the number of metaparameters that you have. And this is now automatically set for you by the calibration tool. We also have the ability to set a random seed for calibration. Constituents have many improvements since Source 3.7. We can now configure constituents to be simulated on a separate time period to your flow. So perhaps if you have constituent data that only spans some of your simulation time period, or if you want to improve performance by only simulating constituents for some of the time period. We've got several new and improved processing models. We've improved the constituent decay algorithm, and also we have a new Broun reservoir sediment trapping algorithm that's available as a plugin. We've also made a number of enhancements to our ability to apply constituent source and filtering models in catchments. We have a new wetland solver that improves performance and improved plugin management. So now you have the option to load plugins from the online rather than from file. And that way, the next time if you've loaded a plugin into Source and you open Source in that model in the new Source version, Source will ask you if you'd like it to download new versions of the plugin from our servers. And that makes plugin management much easier. Okay, thank you very much for listening. That concludes our overview of the new Source features for today. If you're interested in more information in any of these tools, we have 2 one-day courses coming up on the 19th and 20th of October. The first one is an overview of all the new features, and that's on the 19th. The second one will go into several key new features in detail, and that includes scenario input sets and command line running, particularly useful for calibration and running climate ensembles, and the groundwater tool and the calibration wizard. These 2 courses can be taken individually, or you can do them both if you prefer. Okay, thank you very much. We'll open the webinar up for questions before we finish. Okay, thank you very much everyone, and I hope to see you in Canberra in October.